At Kindling, we want our technical findings to inform guidance and practice. Whilst deeper analysis of our data is ongoing, there are a few findings from the tests that are immediately applicable for shelter practitioners and camp planners when it comes to reducing fire spread. A lot of the narrative on fire spread often centres on the idea of a safe separation distance. In the technical sense, a safe separation distance has two functions. One, to eliminate direct flame impingement from one shelter to another, and two, to exceed the distance at which a material can ignite through radiation. However, the idea that there is a certain distance at which shelters cannot spread fire to their neighbours is often impractical for two main reasons. The first is that safe separation distance is often applied as a one-size-fits-all approach, with one separation distance applied irrespective of shelter materials and context. To test this out, let's look more closely at the 2-metre distance recommended in the Sphere Guidance for Humanitarian Settlement Planning. Our experiments looked at different examples of how a neighbouring shelter could be ignited when situated 2 metres from a burning shelter, whether ignited rapidly or not at all. Let's recall the thatch shelter first, where heat fluxes 2 metres away in any direction were so high they could ignite some materials in a matter of seconds. By contrast, in the case of the sheet metal shelter, another shelter at 2 metres away from the door might experience direct flame impingement and high heat fluxes, enough to cause ignition, but due to the large external venting flame at the door. However, based on our recorded heat flux data, it is still likely that there would need to be a prolonged time of exposure before ignition occurred, several minutes rather than a few seconds. Staying with the sheet metal shelter, we also recorded much lower levels of radiation 2 metres away from the sheet metal end walls, where there are no flames projected from a door or window. Here it would be much less likely that a neighbouring shelter could easily ignite. In other words, the thatch shelter burned so hot that it could cause ignition of a nearby shelter in seconds. In contrast, the sheet metal shelter would take longer to spread fire, with the fire spread also dependent on the proximity of a neighbouring shelter to the external flames projecting from an open window or door. So a number like 2 metres is not necessarily helpful. It neither indicates a distance across which fire definitely cannot spread, nor does it give an indication of how fast a fire can spread in a certain direction. It also makes no distinction between plain walls and walls containing a window or door, where the external flames pose the primary fire spread hazard. In reality, these things are always context dependent. The second reason that safe separation distance can be an unhelpful concept is due precisely to the nature of the settlements that these experiments are concerned with. Fire spread is an issue because informal settlements and many managed or unmanaged humanitarian camps are so dense and space is at a real premium. Prescribing a safe separation distance, here we used 2 metres as an example, but in other cases 3 metres has been recommended, can be viewed as impractical and unachievable given the context in which many people live. But by understanding the fundamentals of heat transfer and fire behaviour, we can see that even small increases in separation distance can really help in combating fast fire spread between shelters. First, we know that radiation heat flux decreases dramatically, technically speaking as an inverse squared relationship, with distance from the radiating heat source. We also know that the time to ignition of a material increases significantly as heat flux decreases. So seemingly small incremental gains in separation distance can actually be multiplied to have significant effects. As a very crude numerical example, imagine increasing the separation distance between a burning shelter and its neighbour from 1 metre to 1.2 metres, a 20% increase. The reduction in radiative heat flux has the potential to double the time to ignition of the next shelter. Simply, the fire could take twice as long to spread because of only 20 centimeters difference in the distance between shelters. Now let's think about flame impingement. Remember, this can happen anywhere that there is flame outside the shelter. This can be on combustible walls, but is most commonly from the flame projected from the window and door. We know there are very large temperature gradients in the external flames. Temperatures within the flaming region are upwards of 500 degrees Celsius, but can be over 800 degrees Celsius. However, in the space of a few centimeters, this drops to around 200 degrees Celsius in the hot gases just outside the flames. If 10 centimeters makes the difference between a shelter experiencing direct flame impingement or not, those 10 centimeters can represent hundreds of degrees difference and drastically reduce the time to ignition of the next shelter. The attitude to separation distances should not be that a certain distance must always be achieved, but instead that every 10 centimeters counts. Conventional guidance can often allude to using fire-resistant materials in shelters. Again, this can make sense at face value, but does lack some nuance. In our experiments, we used everything from completely non-combustible materials like sheet metal and concrete blocks, to thatch, which we've identified as a particularly high-hazard material. But context always matters, and this is a game of trade-offs. Choosing a thatch roof over a steel roof might result in completely eliminating projected flames from the windows and doors. However, it provides a large area of material that is easy to ignite and will radiate in all directions as it burns. Bamboo mat burns very rapidly and is easier to ignite than a solid timber facade. But a timber facade has structural integrity for longer, so it is a fire spread hazard for a longer time. And as with the difficulties of separation distance, often a certain material is used because the limitations of the context demand it. With this in mind, the best approach for fire safety might simply be to understand and plan for what materials you already have, rather than searching for alternatives that may pose a completely different set of risks that haven't been accounted for yet.
Pretty crazy here, wow. That's going to be frying all the instrumentation.
Of course, there will always be factors that cause problems with these approaches, none more so than wind, which is unfortunately unavoidable. In our experiments, we saw the extremely long flames and high localized heat fluxes that wind can produce. At times in the year when wind is a particular issue, the approach to fire safety should lean more heavily on preventing fires occurring in the first place, and ensuring that fire services are well equipped and responsive at the highest risk times. These are not things that our experiments have explored directly, but simply a fire cannot spread if it doesn't start, and if it does, the earlier it is tackled, then the better the chance of getting it under control. So for any guidance on preventing fire spread, the context always matters. There is no realistic single separation distance that can mitigate fire spread in all circumstances. Fire spread will always depend on the shelter materials, the wind, and how the shelters are arranged relative to one another. With this in mind, an attitude of every 10 centimeter counts is much more practical, alongside planning for fire prevention and response. We hope these videos have been an informative and useful introduction to the challenges of fire in informal and humanitarian shelters. If you are interested in finding out more about this work, please contact us at fire@kindlingsafety.org.